Hello and welcome to Physics Lesson 3.02, Adding Vectors Graphically. You'll probably want to pause the video for a moment and get a piece of graph paper. And on this graph paper, I have already drawn in colored inks three different vectors, vectors C, D, and E. And we're going to look at how can we add these with graph paper. All right, so hopefully you paused the video, took care of that stuff. And what we're going to work on today, what I'm going to show you is the head to tail addition method. I'm going to leave this side of the paper blank because what we'll do is we'll flip this under when we work on adding these algebraically. So I'm going to try to write on this side of the paper. So the first thing you want to do is choose a vector, and it doesn't matter which one, and I'll prove that to you later. We'll try adding it a different way. And we're going to choose a vector and redraw it. And we're going to go with basic, we're just going to say blocks. Our unit is blocks. But remember, this could be velocity, acceleration, displacement, any vector value. So I'm going to come over here. And when I say that this block has 3 horizontal and 2 vertical, I'm basically resolving this vector. So I'm going to start here, and I'm going to go there, and I'm going to draw vector C. Now I'm going to go to vector E. Vector E, I'm going to go to the left this time. I'm going to go to the left 1 block, and I'm going to go up 1, 2, 3. So I'm going to go left. I'm going to start. So the next step is you start your second vector at the head of the first. Hence, head to tail. So I count over 1 and I come up 1, 2, 3, and I have this. And here's vector E. Now, you know what? I'm going to change vector D a little bit. It's a little too similar. So let's make vector D 2 blocks down. So again, I start at the my third vector at the head of the second. So I'm going to bring my pen up here and I'm going to come down 2 blocks, D. Once you've done this for all your vectors, then you draw your resultant vector. From start to finish. So in other words, you're going to start from the tail of the first to the head of the last. And I'm going to do this in red. So my resultant vector, here is tail of my first, here's the head of my last. I'm going to do an R. If I look at this resultant vector, I'm going 2 blocks over and 3 blocks up. So if I wanted to write R in unit vector notation, I would write this as, and we're going to say that traditional coordinate systems apply, left is positive and up is positive. So I'm going to write this as 2I plus the 1, 2 plus 1, 2, 3J. So these are the components. In other words, I could write this vector as 2 over and 3 up, and my resultant is here. oops, I forgot something too. I forgot to put my positives. I didn't forget it there, but I forgot it on the first one. Well, so I added these three vectors together, but it doesn't tell me what the actual length is. Well, how do we find the length of this? Hopefully your math skills, you remember that the Pythagorean theorem tells us that a squared plus b squared equals c squared. So if I take a, that's 2, that's going to be 4, plus 9 equals c squared. So I have c squared equals 13, so c is going to be square root of 13, which is 3.6 blocks. And again, on graph paper, this is pretty easy because I can just count. Boom, 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 boom. All right, well, maybe you don't believe me. Maybe it's hard to believe that you'll get the same value if you change the order that you add these. Let's just try it and see. So this time, let's start off with E. So I'm going to redraw E. I'm going to come down here. And E is 1 block wide and 3 blocks tall. So 1. So here's E. Now I could draw C, but I'm going to run into my writing. So I'm going to add D next. So let's go to D. D comes down 2, and I'm starting at the head. My tail of the next vector goes to the head of the last. So here's D. All right, and now C is 3 over and 2 up. So if I'm going to start here, I'm going to go over 1, 2, 3, and up 1, 2. There's C. So now I draw my resultant. From the tail of the first to the head of the last, from my start to my finish, and voila, I still have, if I draw in my components for this, 2 horizontal and 3 vertical. You get the exact same results. So the moral of the story is, it does not matter what order you add vectors. Remember, they're not dependent on coordinates. They're kind of their own entities. So this resultant, I could write it 2 ways. I could say, well, so I found my my total length, but I don't have a direction. So how am I going to get a direction? Well, I'm going to need an angle. How do I get this angle? Well, we're going to have to use trig. SOHCAHTOA, tangent tells me opposite over adjacent. So if I do tangent of theta, that's going to be 3 over 2. And when I do inverse tangent, I'm cheating my calculator here, I end up with 56 degrees. And this is going to be, if we do a north, south, east, west, this would be north of east. So the 2 ways, after I add up vectors E, C, E, and D, or D, E, and C, it doesn't matter, I could write the resultant as positive 2I, positive 3J. Or I could write this vector as 3.6 blocks at 56 degrees north of east. These are the exact same thing. This is 2 ways of saying the same thing. But if a problem asks you for the magnitude and direction of a vector, you have got to do this. This gives me components. So this is written in component form. This is written as magnitude and direction. Some people will stop here and they think that they've added the vector. You've got the vector parts, you've got the legs, but you have to get the overall magnitude and direction. So don't make the mistake of stopping short. So what are our takeaways here? On graph paper, we can do head to tail addition method, where we can redraw our vectors with the tail of the second to the head of the first, the tail of the third to the head of the second, so on and so forth, until we get all of our vectors drawn. Once they're all drawn, then we're going to do a resultant from the tail of the first to the head of the last. We use the components of the resultant to find the magnitude and the direction of the resultant. 3.02 has homework assignments where it has you draw these graphically. And then in 3.03, we're going to look at how we do this algebraically. So we'll redo this problem, but we'll do it over here to the side algebraically. And we'll do a few more sample problems and we'll see that the two are pretty related. All right, that's all for now. Thanks for watching and have a great day.